وده كده اختبار بروكتور القياسي ذو 4 إنش. تمام. طبعا دي المطرقة، بس المطرقة دي شغالة على المعدل عندنا بقطر أكبر 6 إنش اللي شغالين فيه في المعمل بالمنظر ده. تمام. طبعا ده بيبقى يدوي. دلوقتي حاليا شغالين على الميكانيكي. الاسطوانة دي بتخش من هنا. تمام. دي الاسطوانة اللي هي ال2 إنش اللي بيبقى فيها المطرقة. تمام. يبقى الشكل او الشغل بتاعنا يبقى بشكل ايه، سريع. ال25 ضربة او اللي هو بقى في المعدل اللي هو 56 ضربة. تمام. بيبقى ايه، بس المعدل ده انت يعني برضو ايه، ده خاص بالمعمل يعني، بس اللي عليك اللي هو 25 ضربة. تمام. فبيبقى بشكل ميكانيكي على طول. طبعا العينة بتاعتي بتبقى حاجة بالمنظر ده كده. والمطرقة لو بصيت هتلاقي ايه، حاجة بالمنظر ده. ده كده بالنسبة لاختبار البروكتور تيست. تقدر تيجي المعمل تبص عليه برضه. طبعا ده الميزان، تقدر توزن العينة بتاعتك. وده كده ايه الفرن بتاعك، تقدر ايه تحط العينة لحد ما تتجفف معاك.
Welcome to the CTTP training videos. ASHTO T99, Moisture Density Relations of Soils using a 5.5 pound rammer and a 12-inch drop. This video demonstrates a standard Proctor test as described in Method A. Attach the mold to the base securely. Zero the scale. Place the mold assembly on the scale platform. Record the mold weight. Attach the collar to the mold assembly. Mix the soil for the first compaction point. Add the first lift of soil to the mold until the mold is about half full. Evenly distribute the soil in the mold. Place the mold on a solid compaction surface such as a sound concrete floor. Using the rammer, gently tamp the soil surface until it is not in a loose or fluffy state. Compact the soil with the rammer using 25 uniformly distributed blows. For each blow, raise the rammer to its full height while making sure the rammer sleeve maintains contact with the soil surface. This will ensure a correct drop height of 305 plus or minus 2 millimeters. Then drop the rammer vertically, letting gravity create the compactive effort. Repeat until 25 blows have been applied, moving the rammer for each blow to uniformly distribute the compaction. Trim the soil around the edges of the mold which extend above the compacted surface. Leave the trimmings in the mold. Add the second lift of soil so that the level comes to about the top of the mold rim. Evenly distribute the soil. Using the rammer, gently tamp the soil. Compact the second lift of soil using 25 blows of the rammer. Trim the soil extending above the compacted surface. Add the third layer of soil so that the soil level is approximately at the top of the collar. Evenly distribute the soil. Gently tamp the soil with the rammer. Add additional soil if necessary before compaction to ensure that the soil level will be above the mold rim after compaction of the third lift. Tamp the soil after any additions. Compact the third lift using 25 blows of the rammer. Carefully remove the collar with a gentle twisting motion to prevent breaking the soil off below the mold rim. Ideally, the specimen should extend about 1/4 to 1/2 inch above the rim. Trim the soil using the beveled side of the straight edge until the soil surface is flush with the rim of the mold. Continue trimming until no more soil can be trimmed off. Patch any voids caused by trimming or rock pop-outs. Retrim after patching. Brush the excess soil from outside of the mold. Also check the bottom of the mold for soil. Zero the scale. Place the mold assembly on the scale platform. Record the mold plus wet soil weight. Remove the mold from the base and extrude the soil specimen. Ideally, there should be 3 equal layers. Zero the scale and place a clean moisture tin on the scale platform. Record the tin number and tare weight. Cut a slice for a moisture content specimen by slicing the extruded soil specimen in half vertically with a knife. From one of the halves, cut about a 1/4 inch slice from the soil sample. This should yield the required minimum moisture content sample of 100 grams. If larger moisture tins are used, thicker slices may be cut. Immediately pick up the entire slice and place it into the moisture tin. Cover the tin with its lid. Zero the scale and place the moisture tin on the scale platform. Record the tare plus wet weight of the tin. Place the lid beneath the tin. Place the moisture tin into an oven and dry to constant mass at 230 plus or minus 9 degrees Fahrenheit. Repeat the compaction procedure for the remaining Proctor points. Remove the tins from the oven and cover with their lids. Cool the samples to room temperature. Zero the scale and place a moisture sample with the tin and lid on the scale platform. Record the tare plus dry weight of the sample. Repeat for all moisture content samples. Calculate the moisture content and dry density for all compaction points. Plot the Proctor points on a graph of moisture content versus dry density and draw a parabolic curve to fit the points. The peak of this curve represents the maximum dry density and corresponding optimum moisture content for the soil. Report the maximum dry density to the nearest 0.1 pounds per cubic foot